Good morning, ladies and gentlemen, and welcome to the Hydrogen Fuel Cells and Batteries Group exhibit. You're here today at the Technical Forum, where we have the next topic of scaled hydrogen boosters for refueling stations as transition technology for clean mobility. I invite you all to please grab a seat, enjoy a coffee, wake up a little bit this morning while we listen to our next speaker. Here with us today, we have the CEO from Reisato International, Mr. Rob Cassian.
Thank you very much for your very kind introduction. We're also very happy to be here at the Hydrogen Forum. And we're also very happy to see that the basic color, everything around here is orange, which is of course the Dutch national color. And tomorrow it's King's Day. Our king is celebrating his anniversary and everything is in orange. I think it's a charming offensive of the Germans to make us the 11th Bundesländer. And then we will be Weltmeister Fußball one day. All right, so let's get started. My name is Rob. I've been kindly introduced, so we can skip this. And we will talk a little bit about hydrogen at Reisato and how we can jointly develop a new hydrogen economy so we can give a green planet to our kids. Okay, so what do we do at Reisato? We are a high-pressure company. And we can make pressure in liquids up to 10,000 bars and in gases up to 5,000 bars. We make safe systems, we design so we can meet the customer needs so they can actually improve their business with our high pressure technology. And we make standard systems like water jet cutting machines, but also tailor-made solutions. So here you have some examples: a water jet cutting machine, oil and gas testing systems, hose testing systems, everything that has to do with high pressure technology. But also now, since 2 years, we got into the hydrogen. Of course, hydrogen is high pressure as well when you refuel cars. And we still have a lot of challenges ahead of us together. But we want to make refueling of cars and other vehicles much more easier and in a transitional manner. So what we've done is, instead of just focusing on big, full-size stations, and of course you have the H2 mobility platform here in Germany. We have, I think, about 75 stations operational right now, but the problem is every station is only serving 5 cars. So there's a lot of big stations, a lot of capital investment, but there's no cars to fuel them yet. So what we thought, we need a transition product, and the transition product, for instance, is a small, scalable and transportable, and you can see here the holes for the forklift truck. You can bring it to the next place again. It's small, scalable, and you can move it around. And you can refuel cars with it. Other things that we do, we supply booster technology, compression technology for bigger stations. We actually can make bigger stations ourselves as well. Here is, for instance, an installation where we refuel buses in the northern part of the Netherlands, where we supplied the booster technology going from 2 bars, very low inlet pressure of the hydrogen, coming out of a chemical plant, and boosting it up to 450 bars, in this case, to refuel buses. Okay, so how can we develop a green hydrogen economy altogether? It's a necessity. I think everybody should be convinced with the Paris agreements, things that are going on in the world, we need to change. And hydrogen is going to be playing a key role in that. So what does the consumer need? He needs a car, and there's some really nice cars outside from Honda, Hyundai, Toyota that you can drive around. We see a nice Mercedes here on the stand. Don't know when we can get that one, but it certainly does look nice. So we need vehicles. But as a consumer, if I need a vehicle, I would like to get some hydrogen in it every now and then as well, right? Otherwise I cannot drive around. So these are the two main things that the consumer needs. You need a car and you need to refuel. But then, if I operate a multi-million dollar, euro refueling station and there's only 5 cars that I'm serving in my area, this becomes a really, really expensive proposition. And in Germany, the initiatives have been taken to put out an infrastructure, but in many other European countries, this is not the case. There needs to be a business case before people do it. So, and the end user is saying, well, if I cannot refuel my car, I'm not going to buy it. So it's the chicken and the egg dilemma, and that's something that we feel we need to break by working with transitional products. So what we figured is that if we have a mother station, for instance, where I have a big electrolyzer that needs to be running continuously to be efficient, if I have a big station, I produce my hydrogen there, or I get it from some other source, I can refuel cars and I can justify maybe in a certain area one big station where I serve multiple cars. But if in many cases today I will have a surplus of hydrogen that I produce locally or I have locally, and what do I do with it? It's not efficient to stop and start the electrolyzer all the time. But what if I can buffer this and I bring it to daughter stations, smaller stations that are within transportable reach of the mother station. Also, these smaller stations should then be at a fraction of the cost, the capital expenses and operational expenses. And that's the concept that we developed. So it could look like this, where you have the blue is the mother station, and you have several stations, smaller stations around the mother station. Here in Hanover or in Bremen, and I have smaller stations where I can bring my excess hydrogen so I can get the economy started. Because if I live here, I maybe want to drive here, but this is still a long way to go with my car. And I don't want to drive 50 kilometers to refuel my car. But then, when the business grows, I can maybe put a big station here, and then I take the smaller station and just move it out. So it's a mobile or transportable system that I can move out to the outside infrastructure of my system. And ultimately you can imagine that if the full infrastructure for hydrogen refueling is developed, these stations would end up in a farmer place where they, with their solar panels overnight, refuel their tractors with a smaller station. So scalable hydrogen solutions for mobility. So at Resato, what we have developed is this small system, but also we have a full-size station. We can also do a full-size station where you can refuel your car in 3 minutes, but you need to be able to do both. So it will take time for us to get this infrastructure going. And what we've said is the modules that we use in the smaller station should be also feasible to be used in the bigger station. So people don't invest in a small station today and think, oh, maybe in 3 years I need to throw it away. No, this technology can also be used in the bigger stations. So it's scalable and you reuse your investment. So here's an example on how things could be scalable. For instance, you start today with a small smaller operation, and you have a bottle supply because you cannot justify the installation of the electrolyzer, it's not running all the time. So you come in, let's say, initially at 200 bars and you lower the bottles until 50 bars. Okay, so that I'm running my system, I pump it up, I buffer it, and I have a dispensing model, and my business model is I will only refuel PKWs, so cars, and no trucks or buses. But at a certain point in time, business is going so well, I decide I'm going to install an electrolyzer. Now suddenly my supply pressure is going lower. So what you can do in our approach is that you just add a module that is already foreseen in the container. Call it a pre-compression module. I have an electrolyzer, I come out with lower pressure, I need one pre-compression stage, and I can reuse the rest of my installation. It's all ready for that. And the next step is I decide I want to refuel some buses. So what I do is I add a second dispensing line, a middle pressure if you want, a buffering module, and now I can refuel buses. But the local bus company decides to buy another couple buses, and I want to further increase my fueling capacity. I can just add another module so I can refuel more buses. And in this way, I can get started with a lower capex, capital investment, and then grow with it as the demand in the market is growing. And that will make my business case much better. All right, so that is about the system approach, but also in our product, we have a modular approach. These are our hydrogen boosters, designed to have no contamination between oil and the hydrogen. Very important to protect the fuel cells in the cars. And these are some of the data that you can see here. We have compressors that go from 4 to 50 kilograms per hour, from 10 to 1100 bars. Today we have a testing system running at the Kiva in the Netherlands. They test automotive parts at 1100 bars, 1.5 times the operating pressure, and it runs 24/7 at 20 kilograms per hour. So just to give you an idea of what we do today. So this is an important part, but also a modular approach. So what we do is, the hydraulic drive is always the same, and I can have different compression heads mounted onto my compressor drive. So what that allows me to do is I can configure the compression system today for what I need today. For instance, I have a slow fill installation. I can have a medium pressure or a low pressure section and a high pressure section. But tomorrow I need more capacity and I can make changes to that. So let's look at a certain use case. I'm having a bottle supply today and I'm coming in with 50 bars and I want to get out at 950 bars to refuel my cars. I need 3 compression stages. From 50 to 180, from 180 to 550, from 550 to 950. Okay, so then the inlet pressure is lowered because I'm starting to use an electrolyzer. So now I cannot use the same compressors setup anymore, or I have a lower capacity. So what do? I just add one stage to the system, and I have a forced compression stage from 10 to 50 bars, and then the rest of the installation remains the same. So I only have one additional booster, and I don't lose any capital investment that I've done previously. And with this modular approach, we can really grow the business together. Another situation that you could have, for instance, our fleet owner station is a unit where you can do a slow fill on your own premises with cars or buses or whatever. And it has only one compressor in it with a low pressure section and a high pressure section. But you can imagine that as the business grows, I want to double the capacity. So instead of buying new compressors, what I can do is I can take the head of my initial compressor, put it on this compressor, and then I just buy an additional compressor to do this. So your investment is protected. Your investment of today is protected for tomorrow. And that's also a very important thing to do. So it's all about the initial design, making systems modular so people can grow with the technology and the demand in the market. Okay. Just a little bit about Resato. We're a high pressure company, that's our core competence. We do different stuff with it, water jet machines, water jet cutting machines, high pressure test systems for oil and gas, all kinds of application, and also hydrogen today. We're located in the Netherlands, 85 people, 20 million turnover. We're growing rapidly, and we go up to 200,000 PSI. This is for the Americans that still have not learned to recalculate the numbers. All right. We do business worldwide. Red are all the countries that we export to from the Netherlands. And we do all kinds of applications in all kinds of industries. You can visit us, look at the fleet owner station where we can refuel cars, slow fill installations at D46. And our experts are there, Francois and Gerard. Gerard, but nobody can pronounce that outside the Netherlands. So we hope to see you there, and maybe there are some questions from the audience.
Thank you so much for that presentation. If there are any questions at this point, I could bring the microphone down to you. And in the meantime, I was just wondering, with respect to your mother station and your daughter stations, you mentioned what would be a reasonable transportable distance. What sort of distance are we talking here?
I think you should be below 75 kilometers, probably.
Okay, so below 75 kilometers. And the other thing that I was wondering, this seems like a really great way to start of lead people into a lower initial investment while still having use of this technology. In a percentage-wise, how much cheaper is it to make a mini station in comparison to a full-blown large-scale operation?
It's about 10%.
Okay, so quite a bit less. Are there any other questions at this time? Oh, yeah, perfect.
I'm Lars Musters from Forza Hydrogen and Electric Racing. I just wanted to talk about that.
Can you speak a little louder?
About that smaller station, the 10%. I think I just wanted to give a compliment about that because I was at a conference where they talked about the return on investment on a full blown station of like 20 years. So I think that would make a great difference. So just a compliment about that idea.
Sorry, I can't.
No, I just wanted to give a compliment about the idea. Yeah.
Thank you. Okay, so on that note then, I think we'll call it. If you do come up with any other questions, feel free to drop by the booth. You are at D46/1, and will you be here for the rest of the fair?
I will be here today, but tomorrow I need to celebrate the King's birthday. So I go back, but my colleagues are here.
Okay, well, if you would like to speak with Mr. Castien in person, make sure you drop by sometime today. Thank you all for your attention, and thank you so much for that presentation.
Thank you.
At this point, I'd like to invite all of the audience to remain here. We have our next presentation in just a few moments. We'll be learning about fuel cells and hydrogen technology development at CNH2. So stay tuned. We'll be with you in just a few moments.